My name is Thibault Bonnemain, and I'm from King's College London. I'm more of a physicist actually than a mathematician. So for me, math is more of a language or a set of tools to do physics rather than a field of research to explore. So I would leave that to real mathematicians to do actually. But what interests me about math is its ability to condense information. So technically you could write an equation in plain English, but it might take pages, whereas if you write it in math, it might just take one line. So it allows me to take a step back, think of a problem more globally, don't get lost in unnecessary details, maybe find similarities between objects that a priori have none, and ultimately, approach something more objectively and find solutions to problems that might be counterintuitive. What I do is I work on Soliton gases, Generalized Hydrodynamics, and mean-field game theory. So those are three subjects that at first may seem very different, but are tied together through this idea of emergence. So the fact that from basic interactions of like two particles or two solitons, two waves if you will, or two agents like pedestrian and a crowd, how you can see or explain the emergence of collective counterintuitive behaviors, right? So in practice what I do is I look at nonlinear PDEs, and I try to use tools of integrability to study them and see how I can introduce randomness. CPS Bursary helped me with my accommodation here during my stay for the semester-long program on dispersive hydrodynamics here at the Isaac Newton Institute, Cambridge. Funding is really important for early career researchers especially, because it can be very time-consuming to find funding, and so the CPS Bursary helped me with that and removed that worry.